Alright, last lesson of the unit, and we're really not learning anything new. We're just taking the previous knowledge and applying them to these more complex problems, or as I like to say, the more fun problems. Now if we look at number one, we're just going to start with the basics. These are all going to be examples of triangles that overlap one another. And so the first thing I want to work on is just breaking these triangles apart so that we can kind of see what's going on. Now if you notice, you got this triangle right here, BAD, in green, sitting right on top of triangle CAD in purple. And so the first thing I want to do is just separate these two things. So we got CDA and BAD. Now you should notice, especially if you highlight it like I did, if you have colored pencils or markers or highlighters, that when we highlighted, we kind of went over this in purple and we went over this in green. That anytime you have two triangles overlapping one another, they're going to end up sharing something. And in this case, they share this segment right here. And it wants us there to just name the common. And the word for common is just talking about things that they share, they have in common. And they have AD in common with AD. They share those two things. And we're not proving anything in number one, just breaking it apart so we can see what they share. Looking at number two, we got this triangle, WRS, sitting on top of this one, and we're going to see over here we have some things being shared. And let's break these apart. We got WRS and TRQ. Okay, now maybe your first thought is that this is kind of, this line, we had purple and we had green, so they're kind of sharing this. But notice this segment is not the same over here. That's just a piece of this line. So we can't necessarily say that this is shared with that one. This just kind of shares a part of that. So that doesn't really count. But what we should notice is that they share this angle. You can have shared sides and shared angles. They share this angle R right here. In this green triangle, it's that angle right there, which is angle R. And then in that purple triangle, it's the same thing. It's the same exact angle right there. And so they share angle R in both triangles. Okay, the last one looks a little crazy, and it tells us over here which ones we want to separate. And that's just PSU. So I'm going to do that one in green. PSU, and then QVT is sitting right on top of it, right here. QVT. Okay. Now here, as I'm looking, I'm scanning through, P and Q aren't really shared. These angles aren't really shared. They share part of this line, but not the whole line, and nothing else. So this actually, even though it's got all this stuff going on, they don't actually share anything. They're just kind of sitting on top of each other, but they only share this part of the line, but not a whole line.
That makes sense.
All right.
Okay.
Moving on to number 4, because now that we've broken them apart and separated them, I want to now just take something like this. Because you're going to look at this and say, oh man, this looks so hard. But the first step is just break it apart, and then we can use it to prove what's going on. So right now, let's look at this triangle. And if you don't have colored pencils, you may want to pause the video and go run and get some, because it definitely does help just to visualize what's going on here. Okay, so right now, I'm just going to come over here to the side and redraw. The green one and the purple one. You got R, U, S, P, Q, T. Now these little arrows we've seen on several of the examples we've done before. These mean that the lines are parallel. And anytime you see parallel lines, you got to think back to what we learned in Unit 1, is that's alternate interior angles or corresponding angles or same side interior. Okay, and in this case, this one and that one are corresponding. Okay, and you should remember that corresponding angles are always equal. And so that's going to be our first step, is that angle P is the same as angle U because they're corresponding angles. Alright, then we have another set of parallel lines, and these just use two arrows so that we don't get this line confused with that. These are obviously not parallel to each other, but this one with two arrows is parallel to the other one with two arrows. And again, you have the same thing going on down here, is that that and that are also corresponding angles. So that's S and that's T. So S is the same as T because they're corresponding. And this symbol is just meaning angles. And now we know, at this stage, we know that we need a third thing, because we always need three in all of them. And just like in this example, just because they overlap doesn't necessarily mean that they share anything. They share this little part of this line, but a part of a line is not good enough. If you look up here, we skipped probably the easiest step, and that was just they gave it to us and told us that TQ is the same as SR. Okay, and that's why we separate the triangles, because it gets hard to mark on here because there's just so much going on. But if you separate them, it makes it easy. But TQ is going to be the same as SR. That's given to us. And you could have wrote that first. We probably should have wrote that first, but the order doesn't matter. But we have an angle, we have an angle, and we have a side. So we have enough now to prove these triangles are congruent. So we'll say triangle QTP is congruent to triangle, and I'm just going to go in that same order, RSU, because of angle, angle, side. You may have started with the side, and you could have said side, angle, angle. That's the same thing. It's fine. What you can't do is start here and say angle, side, and skip all the way around to an angle. You got to go in order. So angle, angle, side. Right, and we've proved those triangles congruent now. But let's look at the instructions, because the instructions ask us to prove that PQ is the same as UR. And if you remember back to yesterday's lesson, we just now have to go that final step and say, well, if these triangles are exactly the same, if this Pontiac Vibe is the same as this Pontiac Vibe, well, then this steering wheel's got to look just like this steering wheel. This tire's got to look like this tire. The CD player's got to look like this CD player. If the triangles are the same, all of their parts have to be the same. And so we know that this part over here has got to match up with this part over there. PQ has got to be the same as UR. And what we called that was CPCTC. CPCTC.
What does that mean again?
That means corresponding parts of congruent triangles are congruent. So corresponding parts, like matching parts of congruent, the same triangles, are congruent.